Download this code from codegive.com, link in the description below. AMD Ryzen Memory Issues, a comprehensive troubleshooting and tuning guide. Ryzen CPUs, particularly the first and second generation, gained a reputation for being sensitive to memory speeds and timings. While newer generations are less affected, achieving optimal performance still requires careful attention to RAM compatibility, configuration, and stability. This comprehensive guide will walk you through understanding, diagnosing, and fixing common memory issues with Ryzen systems, including code examples for testing and monitoring. Understanding the Ryzen memory landscape. Before diving into troubleshooting, it's crucial to grasp the key concepts. Infinity fabric, if the interconnect that allows the CPU cores, ccxs, and the I/O die to communicate. The if clock speed, fclk, is ideally coupled 1:1 with the memory clock, mclk. A lower fclk than mclk significantly impacts performance. This is known as an asynchronous configuration. Memory controller, IMC integrated directly into the CPU, the IMC manages the interface between the CPU and RAM. Its capabilities directly influence the supported memory speeds and timings. XMP/DOCP Extreme Memory Profile, Intel, or Direct Overclock Profile, AMD. These are pre-configured memory profiles stored on the RAM modules by the manufacturer. They automate the process of setting timings and voltages for optimal performance. Timings, co-latency, TRCD, TRP, TRAS, etc. These control the delays in memory access. Lower timings generally mean better performance, but can lead to instability if set too aggressively. Voltage, VDIM, VDDCR_SOC, VDDP, VDDGCCD/IOD. Supplying the correct voltage is essential for memory stability. Incorrect voltage can cause errors or even damage hardware. VDIM is the voltage supplied to the DRAM modules. VDDCR_SOC, or SOC voltage, is the voltage supplied to the system on a chip, which includes the IMC. VDDP and VDDG, CCD/IOD, are less commonly used voltages that may require adjustment for very high memory clocks. Dual channel versus single channel. Ryzen benefits greatly from dual channel memory configuration, achieved by installing RAM sticks in the correct slots on the motherboard, usually specified in the motherboard manual. Single channel significantly bottlenecks performance. 2. Common Ryzen memory issues and symptoms. Boot issues/black screen. The system fails to post, power on self-test, or get stuck in a boot loop after changing memory settings. System instability. Random crashes, blue screens of death, BSODs, application errors, or freezes during gaming or other demanding tasks. Performance bottlenecks. Lower than expected performance in benchmarks or games, especially noticeable when compared to similar systems with faster memory. Error codes. Specific error codes displayed during boot or crashes, often pointing to memory issues. Examples include memory management errors or checksum failures. Corruption of data. Rare but possible, corrupted files or data due to memory instability. 3. Troubleshooting steps, a step-by-step guide. 1. Verify RAM compatibility, crucial. Motherboard QVL, qualified vendor list. The first and most important step is to consult your motherboard's QVL. This list, available on the motherboard manufacturer's website, example ASUS, MSI, Gigabyte, ASRock, specifies which RAM modules have been tested and verified to work with that particular motherboard. While other RAM might work, sticking to the QVL significantly reduces the chance of incompatibility. Ryzen CPU specifications. Check the official AMD website for the supported memory speeds and configurations for your specific Ryzen CPU model. Exceeding these specifications isn't necessarily a problem. Overclocking is common, but it provides a baseline for compatibility. RAM specifications. Know the specifications of your RAM. Speed, megahertz. The rated speed, example 3200 MHz, 3600 MHz. Timings, CL, TRCD, TRP, TRAS listed in the format CL, TRCD, TRP. TRAS, example 16-18-1836. Voltage, VDIM. The required voltage, example 1.35 V. Single rank or dual rank. Dual rank RAM modules typically offer better performance, but may be more demanding on the IMC. Refer to your motherboard's manual for recommendations. This information is often printed on the RAM modules themselves or found on the manufacturer's website. 2. Hardware inspection and basic configuration. Proper installation. Ensure the RAM sticks are firmly seated in the correct DIMM slots for dual-channel operation. Consult your motherboard manual for the correct slot configuration, usually A2 and B2 or A1 and B1. Double-check that the clips are fully engaged. RAM stick health. If you have multiple RAM sticks, try testing them individually. Boot the system with only one stick installed. If it boots successfully, test the other stick, individually. This can help identify a faulty RAM module. BIOS version. An outdated BIOS can cause memory compatibility issues. Update your BIOS to the latest version available from your motherboard manufacturer's website. Be extremely careful when flashing the BIOS, as a failed update can brick your motherboard. Follow the manufacturer's instructions precisely. Reset BIOS to default. Clear the CMOS, complementary metal oxide semiconductor, to reset the BIOS to its default settings. This can be done by removing the CMOS battery, a small watch battery on the motherboard, for a few minutes, or by using the CMOS clear jumper. Refer to your motherboard manual. This helps eliminate any conflicting settings that might be causing problems. Cooling. Ensure adequate cooling for your RAM. Overheated RAM can cause instability. Consider adding airflow over the RAM modules if necessary. 3. Enabling XMP/DOCP, and understanding its limitations. Enable in BIOS. Access your BIOS settings, usually by pressing Delete, F2, F12, or ESC during startup. Check your motherboard manual. Locate the XMP or DOCP setting, the name varies depending on the manufacturer, and enable it. Monitor results. After enabling XMP/DOCP, observe your system's stability. If you experience crashes or boot issues, XMP/DOCP might be too aggressive for your setup. Manual tuning. If XMP/DOCP fails. If XMP/DOCP is unstable, you'll need to manually tune the memory settings. This involves adjusting the memory speed, timings, and voltages in the BIOS. This is where careful experimentation and documentation are key. For manual memory tuning, a detailed approach. Start with safe settings. If XMP/DOCP is failing, start with the following settings as a baseline. Speed. Reduce the memory speed to the next lower supported value. Example, if your RAM is rated for 3600 MHz and XMP is failing, try 3200 MHz or 3000 MHz. Asterisk timings asterisk loosen the timings slightly, increase the numbers. For example, if your RAM is rated for 16-18-1836, try 18-20-20-40. Asterisk voltage asterisk start with the voltage specified by the RAM manufacturer, usually 1.35 V for DDR4. You might need to increase this slightly, but avoid exceeding 1.45 V for everyday use. Asterisk SoC voltage, VDDCR_SoC. This is critical for Ryzen memory stability. Start around 1.05 V and increment upwards. Do not exceed 1.2 V for 24/7 use. Some users may need to increase this voltage even when running at default memory speeds. Asterisk step-by-step increments asterisk make one change at a time and thoroughly test for stability before making another change. This is crucial for identifying the specific setting causing problems. Asterisk testing for stability asterisk use memory testing tools like memtest86 Plus or test MEM5, TM5, to stress test the memory. Asterisk memtest86 Plus asterisk a bootable tool that runs independently of the operating system. It's highly reliable but can take several hours to complete a thorough test. Download the latest version and create a bootable USB drive. Asterisk test MEM5, TM5 a more aggressive and faster memory testing tool, but it requires Windows. It's considered very effective at identifying memory instability, even after memtest86 Plus passes. You'll need to find configuration files, configs, specifically designed for TM5 testing, example the ANTA777 or extreme configs, from reputable overclocking communities. Search online forums and Reddit for TM5 guides. Asterisk voltage adjustments asterisk. Asterisk VDIM asterisk increment VDIM in small steps, example 0.01 V or 0.02 V. Monitor memory temperature to avoid overheating. Do not exceed 1.5 V without adequate cooling. Asterisk VDDCR_SoC asterisk crucial for Infinity Fabric stability. Increment in small steps. Excessive voltage can damage the CPU. Monitor CPU temperature. Asterisk VDDP/VDDG asterisk these voltages may help stabilize higher memory clocks and tighter timings, but are more advanced. Consult overclocking guides and forums for specific recommendations. Generally, keep them relatively close to each other and slightly lower than VDDCR_SoC. Asterisk timing refinement asterisk once you've found a stable memory speed and voltage, you can try tightening the timings to improve performance. This is an iterative process. Asterisk primary timings, CL, TRCD, TRP, TRAS focus on these first. Decrease the numbers one at a time, testing for stability after each change. Colatency, CL, has the most significant impact on performance. Asterisk secondary and tertiary timings asterisk these timings are more complex and have a smaller impact on performance, but they can still contribute to stability. Consult guides specific to your RAM type and Ryzen generation for recommended values. Tools like Ryzen Timing Checker, RTC, can help you monitor the current timings. 5 software tools for monitoring and testing. Asterisk CPUZ asterisk displays detailed information about your CPU, motherboard, and RAM, including current speeds, timings, and voltages. Download from https://www.pwide.com/softwares/cpuz.html, https://www.cpuid.com/softwares/cpu-z.html. HWINFO64 provides comprehensive monitoring of system sensors, including CPU temperature, RAM temperature, if available, and voltages. Download from https://www.winfo.com/ https://www.hwinfo.com Ryzen timing checker, RTC, a utility specifically designed to read and display memory timings on Ryzen systems. Download it from overclocking forums, search for Ryzen timing checker plus your CPU generation. This tool is invaluable for verifying the timings you've set in the BIOS. *memtest86 plus *, as mentioned before, bootable memory testing utility. Download from https://www.memtest86.com/ https://www.memtest86.com *test MEM5, TM5, as mentioned before, Windows-based advanced memory testing. Requires configuration files. Search for configs on overclocking forums like overclock.net or Reddit r/overclocking. 4. Code examples. While you can't directly control memory settings with code outside of BIOS modifications, which are extremely dangerous and not recommended, you can use code to monitor memory usage and perform basic stress tests to complement the other testing tools. Python, using sutil, memory usage monitoring **. Explanation *. 1. Import sutil *. This library provides access to system information, including memory usage. Install it using pip install sutil. 2. Get _memory_info, *. This function retrieves memory statistics using sutil.virtual_memory. It returns a dictionary containing total, available, used, and percentage of memory used. 3. Display _memory_info, *. This function formats and prints the memory information in a user-friendly manner. 4. Main loop *. The while true loop continuously retrieves and displays memory usage information every second. The try, except keyboard interrupt block allows you to stop the monitoring by pressing Ctrl+C. How to use *. 1. Save the code as a .py file, example memory_monitor.py. 2. Open a terminal or command prompt. 3. Run the script, Python memory_monitor.py. 4. The script will continuously display memory usage information until you interrupt it. This can be useful for observing memory usage while running stress tests. Python, using multiprocessing, basic memory stress test *. Explanation *. 1. Import libraries *. Imports multiprocessing for creating multiple processes, time for delays, and random for filling the memory. 2. Memory_hog, PID, function *. Allocates a specified amount of memory, defaulting to 1 GB, using byte array. Byte array is mutable, allowing for in-place modification without reallocation. Optionally fills the allocated memory with random data. This increases the stress on the memory. Enters an infinite loop that periodically touches the memory at random locations. This helps prevent the operating system from swapping the memory to disk, keeping the stress on the RAM. Handles keyboard interrupt to allow the process to be terminated gracefully. 3. Main block, if __name __= main__; determines the number of processes to create based on the number of CPU cores. Creates a list of multiprocessing .process objects, each targeting the memory_hog function. Starts each process. Uses p.join, to wait for all processes to complete, or be terminated. Includes a try, except keyboard interrupt block to handle the termination of all processes if Ctrl+C is pressed. How to use asterisk. 1. Save the code as a .py file, example memory_stress.py. 2. Open a terminal or command prompt. 3. Run the script, Python memory_stress.py. 4. The script will start multiple processes, each allocating and using a significant amount of memory. 5. Use the memory_monitor.py script, or task manager, to observe memory usage. 6. Let the test run for a period of time, example 30 minutes or more, to see if any errors or crashes occur. You can adjust the allocated memory amount, size_GB, and the number of processes, number_processes, to tailor the test to your system. 7. Press Ctrl+C to stop the test. Important notes on code examples asterisk. These code examples are supplementary to more robust memory testing tools like memtest86 Plus and TM5. They are primarily useful for observing memory usage and performing a basic load test. They are not a substitute for thorough memory testing. Memory errors might not be immediately apparent. It can take hours of stress testing to uncover instability. Adjust memory allocation size. Modify the size_GB variable in the memory_stress.py script to control the amount of memory allocated by each process. Make sure you don't allocate more memory than your system has available, or it will start using swap space, which will defeat the purpose of testing the RAM. Monitor system resources. Use Task Manager, Windows, or top/top, Linux, to monitor CPU usage, memory usage, and system temperatures during the stress test. High temperatures can indicate a problem with cooling. Safety. Be cautious when overclocking and adjusting voltages. Excessive voltage can damage your hardware. Start with small increments and carefully monitor temperatures. If you're unsure, consult with experienced overclockers on forums like overclock.net. Advanced tips and considerations. Gear down mode, GDM, a BIOS setting that forces the memory clock to run at half the specified speed if it's unstable. It's a last resort to achieve stability, but it reduces performance. Disabling it is ideal for optimal performance if your memory can run stably at the full speed. Power down enable, PDE, another BIOS setting. Disabling it can sometimes improve stability with certain RAM modules. PROCODT, on-die termination and impedance matching setting that can improve signal integrity, especially at higher memory speeds. Consult overclocking guides for recommended values based on your RAM and CPU. Increasing this may help with stability. Memory training. During boot, the motherboard's BIOS performs a memory training process to optimize memory settings. If this process fails, it can lead to boot issues or instability. Ensure your BIOS is up to date to benefit from the latest memory training algorithms. Power cycling the system several times can sometimes help improve the memory training process. BIOS settings specific to RAM chip manufacturers, Samsung B-Die, Micron E-Die, etc. Different RAM chip manufacturers, example Samsung, Micron, Hynix, have different characteristics and optimal settings. Overclocking guides often provide specific recommendations for different chip types. You can identify the RAM chip manufacturer using software like Typhoon Burner, Windows. NUMA, Non-Uniform Memory Access. Ryzen CPUs use NUMA architecture. Ensure your operating system and applications are NUMA aware for optimal performance. Cooling is critical. Keep your RAM modules cool. Consider adding airflow or using RAM coolers if you're pushing the limits of overclocking. Overheated RAM can lead to instability and errors. Consult overclocking communities. Overclocking forums and Reddit communities, example r/overclocking, are valuable resources for finding information and getting help with Ryzen memory overclocking. 6. When to consider upgrading or replacing components. Incompatibility. If you've tried all the troubleshooting steps and are still unable to achieve stable memory operation at the advertised speeds, your RAM might simply be incompatible with your motherboard or CPU. Consider replacing the RAM with a kit that is specifically listed on your motherboard's QVL. Faulty hardware. If individual RAM sticks fail memory tests, they are likely faulty and need to be replaced. CPU limitations. Some Ryzen CPUs may have limitations in their IMC that prevent them from achieving high memory speeds. Upgrading to a newer generation Ryzen CPU with an improved IMC might be necessary. Motherboard limitations. Some motherboards have better memory support than others. If you're consistently struggling with memory stability, consider upgrading to a higher quality motherboard. 7. Summary. Ryzen memory issues can be frustrating, but with a systematic approach, careful troubleshooting, and a willingness to experiment, you can often achieve stable and optimal memory performance. Remember to prioritize compatibility, follow a methodical testing process, and consult with experienced overclockers if you need assistance. Good luck.